Here are solutions to test number 1 for ECE 461-661 control systems. The first problem is looking at ladder logic. What's the logic for this function? Well, in this case, series is AND, parallel is OR. So this would be A bar and B and C or Y bar is X on the bottom rung. Y is A and C bar or X and B bar. On to problem 2. This is the Jeopardy question. Name that system. This is clearly a second order system because it's oscillating. So I've got a complex pole and its complex conjugate. To get the real part, I can look for the settling time. Here the settling time is right around here. Call it 225 seconds. So A is going to be 4 over the settling time. I'm giving you 17.78. To find B, I measure the frequency. So this is 1 cycle, 2 cycles, 3 cycles, 4 cycles. This one's kind of convenient. So the frequency is 4 cycles in 125 milliseconds. That gives you hertz, and anything English is wrong. So to convert to natural units, multiply by 2 pi, gives you radians per second. Then K sets the DC gain. DC gain should be right about here. So here's 1.4, 1.6, right about 1.48. So putting all that together, I get the real part of the pole, the complex part of the pole, and the DC gain. I guess I said 1.45. Make the numerator whatever it takes to make the DC gain 1.45. Problem 3. Find the transfer function from x to y. Now there's a couple approaches. One is the shortcut. I would say going from x to y, here's one path, BDF. Here's another path, ADF. And that's about it. So that's the numerator. The denominator is 1 plus the loop gains. So here's one loop, BD. Here's another loop, DE. Here's a third loop, BDFG. That's the shortcut. That usually works, occasionally misses terms. The long way always works. The long way would say, put a variable at the end output of each summing junction. So M is X minus BCM. N is A times X minus EDN plus B times M. Y is F times D times N. Now comes some algebra. Let's take this equation, solve for M. Substitute. I now have M going in here, solve for N, and clear the denominator, bring all the N's left, and solve. That's what N is equal to. Now substitute. N goes in here. Clear the denominator, bring all the Y's left, and here's the answer. And if you notice, the shortcut actually does miss 2 terms. There's an extra term in the numerator, and there's an extra term in the denominator, BDFG, right here. So in the numerator, there apparently is another path. That's the FDCBA. So FDCBA, apparently. I don't see it, but it is there. And there's also a CBED as a loop. CBED. Oh. Shortcut mostly works. Occasionally does miss a term. Problem 4. Give the dynamics for this RLC circuit. So here the trick is I equals C dV dt. And for inductors, V is L di dt. So for the first capacitor, I1 is C dV dt, 0.1 V1 dot. That current is the excess current. So the current in is Vn minus V1 over 4, minus this current, minus V1 over 7, minus this current, V1 minus V2 over 5. Anything left over is I1. For current I2 is the current from the left, V1 minus V2, plus this current, I4, minus this current, V2 over 8, minus this current, V2 minus V3 over 6. I3 is the current from the left, V2 minus V3 over 6, minus this current, V3 over 9. Then for the inductors, the voltage across it is L d I dt. So this voltage is Vn minus 3I4 minus V2. So those are the dynamics for this circuit. The last problem is, given the dynamics, say for mass spring system, put it in state space form. The trick is solve for the highest derivative, so solving for s squared x1, bring everybody else right, gives you minus sign, plus sign. Solve for s squared x2, then in state space what I'll have is sx1 is just x1, sx1, as x2 is sx2, that's the zero identity matrix. This shows up down here. Minus 2s x1, minus 4 x1, plus 5s x2, plus 6 x2, plus 0.5f. The second equation, 0.4s x1, 0.4 sx1, minus plus 1.2 x1, minus 3s x2, minus 6 x2. And the output is x1 minus x2. There's x1 minus x2. So that's test number 1 for 461, 661 control systems.